Hey, what's up nerds? Mike here. Listen, before you start with the lesson that you're about to watch, I just want you to know that it's actually a small part of a bigger course that I created on NSX-T troubleshooting. So if you like what you see in this course, check the description below for a link where you can buy the full course, and be sure to use the coupon code NERDYNATION, that's NRDY Nation, N-A-T-I-O-N. Use that coupon code and that will give you 70% off the regular price. Don't pay the full price, totally not necessary. That said, I'm gonna let you get to this lesson. I hope you enjoy it and come back for more. Take care and stay nerdy. I don't know what I was doing. I'm just gonna pretend I'm doing something important on my iPad. All right, welcome back. In this lesson, I'm going to show you how to do a packet capture on an ESXi host. Now, this isn't an NSX step of troubleshooting, but it is part of the bigger picture. And so when I created this course, I weighed back and forth over whether I should show this. And I decided that yes, if you're going to operate in NSX-T environment, you should know how to do a packet capture on your ESX host. So let's get to it. Let's start talking about a couple of different options you have in terms of tools, and then we will get into implementing it. So without further ado, I like to label this one as one host, two tools. It sounds like a setup for a great movie series. I'm not sure if I'll get any traction on it, but I'm persistent. That said, there is two tools when it comes to running packet captures inside of ESXi, and if you've been around for a little bit, you might be more familiar with this one, TCP-dump-UW. This is designed ultimately to capture basic traffic coming through the host and ultimately the VM kernels. Now, it is worth mentioning that you cannot specify a capture point that is at a virtual point or a virtual switch, or I'm sorry, a virtual port, or at a virtual switch, or you can't actually even capture directly at the VM itself either. So you can only capture at one place with this tool. And that kind of brings me to the next point, which is we only have one capture point. The challenge here is that the packet might have been altered or changed or looked differently, or maybe not even making it all the way to the VM kernel, and we have no visibility with this tool. So that kind of makes sense that this is a slightly older option. There is a newer one which VMware introduced, and ultimately, as long as you're on anything newer than, I believe, 5.560, somewhere in there, you should have access to this one. It is PKT cap, packet cap -UW. This one is newer and a lot more flexible, and what I mean by that is ultimately it's going to show us raw packet output. So if you were to run a capture with this and a capture with this side by side, TCP-dump-UW will decipher some of the packet for you, so it's a lot more human readable, which makes it tempting to use this, but this one is much more powerful. So even though it is showing us the raw packet output, we can easily save that to a file and send it to a workstation running something like Wireshark so we can actually analyze that packet. And again, I'm actually going to show you how to do that. Now moving on, what I was going to say a minute ago was that with this option, we can actually capture the physical interface traffic, or traffic going in and out of the physical interface, the VM kernel, just like this one over here. But we can also capture at different points. In this case, we can capture at the virtual switch, before the virtual switch, after the virtual switch, same thing for the virtual port. And we can actually even specify a physical uplink. So we can say capture traffic going out of VM-NIC 6, for example. So we have a lot of flexibility in where we capture with this tool. And that brings me to the next point, which is, like I said, just one brief example is we could say, hey, we have a virtual switch, maybe a VDS or a VSS. We can run this capture tool to see packets before they enter that virtual switch, and we can check to see if they're leaving it. Clearly, if they don't leave it, we know we have some kind of issue with our virtual switch. So this is a really, really great tool to have in your arsenal. Now that said, I'm not going to go over the TCP-dump-UW tool because it is older. It's still definitely valid, but it is older. There's a lot of documentation on that one. But I wanted to give you a couple of examples of this one, packet cap, before we actually go into the lab. Now, the first thing I want you to know about this tool is all captures will default to inbound traffic or the inbound direction by default. You can change this, but you need to specify the direction you want to capture by adding this little tag here, --dir, short for direction. 0 will be inbound, 1 will be outbound, and you guessed it, 2 will cover both inbound and outbound traffic. So just to recap, if you don't specify any of these, you are only looking at inbound traffic with this tool. Now, here's an example of what it would look like to capture actual VM kernel traffic, which is really helpful because we're going to do this. So in this case, the syntax is pretty straightforward. You're going to SSH into your host, and from there, from the ESX terminal, you can actually run packetcap-uw. In this case, we did --vmk. That's short for VM kernel. So then we specify the ID we want to capture, or which VM kernel do we want to capture traffic on. We can also capture traffic, like I said, on an actual uplink. So in this case, instead of saying VMK as our option, we can say uplink, and we specify the VMNIC number. So that would be the actual number of our physical adapter. Now, I do want to mention the output you will see here is basically useless. So you will probably want to send this to some kind of packet analysis station. And the way that you would do that is by saving the output directly to a PCAP file on your host, and we will then copy it off of the host for later analysis. The way that you can do this is just by adding -o and then the path to where you want to save the PCAP. And in this case, I'm saving it to /tmp/test.pcap, and then I could later use something like scp to copy this file off to my workstation. All right, there's just a couple of examples here. The best way to get familiar with this is going to be doing packetcap-uw-h. And if you add pipe more, this will make it a little more easy to navigate some of the options because there's quite a number of options. Another thing I will tell you that you will see once we get into the CLI is that there is no easy way to specify a regular TCP port. You'll have to specify a protocol number. And again, I'll show you what that kind of looks like. All right, so from here, let's flip over to the lab and get started. All right, so here we are in our lab, and we have London Compute 1 and 2. Now, what I want to do in this case, so we're going to kill two birds with one stone here. So what that really means is we're going to get two things done here by accomplishing one lesson. And that is in our BFD or bidirectional forwarding lesson, we talked about how BFD is exchanged between these hosts constantly. Well, we're trying to learn how to capture packets, and what better way to capture a packet or learn how to do it than actually do it? So we are going to set out on an objective here. We want to capture packets between London Compute 1 and 2 that are BFD, the bidirectional forwarding packets. This would be one of our troubleshooting steps if we were having problems with overlay networking between the two. So the first thing I'm going to do before we leave vCenter for good, we're going to head over to Configure. And I've selected London Compute 1. Now I just want to go to VM kernel adapters. This is just identifying which one we're going to capture on. In this case, we're looking for VMK10. That is the one created by NSX for our TEP traffic or our overlay traffic. So the BFD traffic will be between this IP 19.20 and let's go to this other host. 19.21 is the IP of this other one. So that's the capture point, and we're going to capture between those two interfaces. So what we need to do is open up an SSH session, and if we just clear here, I'm going to show you what the actual syntax here looks like. So if I do pkt cap-uw and I do -h, this will give you the syntax that I was just talking about. So if I scroll up here quite a bit, there's a lot. Let's see. Right. There we go, right here. So we can see the actual syntax here to capture. So we specified that part, that's good. I mentioned the direction. If we wanted to do a direction other than inbound, we could use this option here. We also have to decide where we're going to capture. In this case, we could capture at a switch port on one of our switches, our virtual switches. We could also specify a VM kernel adapter, which is what we'll be doing. And finally, we could also specify a physical uplink. Like I said, we could say vmnic 2 or 3, for example. All right, so in our case, though, and the last thing I wanted to throw out here, actually, before we get started, I mentioned you can't easily specify a regular protocol, so you can't do something like packet cap -uw -- VM will capture on VM kernel 10. That's what we said. And then you can't do something like P80 for port 80. That doesn't work with this tool. What you actually have to do is right here. You have to specify --proto. So I'm going to copy and paste that down here. And then you specify the actual protocol number. So it's going to start with 0x and then something. So you probably won't know this off the top of your head. So what I actually refer to is there's actually a Wikipedia page that just lists IP protocol numbers, and it maps them to the hex value. So for example, if you wanted to capture ICMP traffic going through this interface, we would specify 0x01. So we would do something like 0x01, and that would capture ICMP traffic. Now, clearly we're not pinging this interface, but that's how we would capture that traffic coming through. Okay, so I'm going to clean this up a bit. Let me just I'll make this full screen for right now. Now, what we want to do, like I said, we want to actually capture something very specific. So we are going to get around this little limitation like I showed you right here. This can be kind of cumbersome. There is a way you can actually make it a little easier. So what I'm going to do is actually, you know what, before we do that, let's do packet capture UW help. And I want to show you, see if we can find this. Okay, so there is this other option, and it is by specifying UDP port, and you can actually do TCP as well. So you can see right here, this is the option right here, --TCP port. This will match if it is a source or destination port, and the same is true of if we just did UDP port here, this one right here. So in our case, what we're going to do, let's build this out together for this packet capture. We're going to say packet cap -uw. We then need to specify our capture point. We're going to capture VM kernel 10, VMK10. We're going to specify a port. We're going to do UDP port 3784. That is one of the ports used for bidirectional forwarding. So we want to make sure we see that traffic. Next, we're going to specify an output file because we want this to be captured locally so we can transfer it to our workstation that has Wireshark on it and actually do analysis on this. To do that, we just specify lowercase -o. Then the path, I'm going to use the TMP directory on this host, and I'll name this test1.pcap. So I'll hit enter there. All right, so we can see here there is a couple of entries showing up here that probably make it very difficult to understand what's going on, but we are actually capturing. So I'll just confirm that here. I'll stop the capture. And now what I'm going to do is I'm going to first do an ls. So I'm going to do a lookup with Linux in the TMP directory, and I'm going to match based on pcap. So we can see that there is a file now written in that directory called test1.pcap. And if I add an ls-l here, so I can see the file size, that'll actually show us that there is something in this file. Now, unfortunately, if I were to do cat tmp test1.pcap, you can see it's not human readable. So it is definitely a pcap file, but unfortunately, as you saw a minute ago, we can't really do much with this right here. So what we need to do at this point is use SCP, or Secure Copy Protocol, to copy this file to our workstation. Now, I've done no configuration on the ESX host, none. I haven't set up anything, but what I am going to use is WinSCP. That is, just to show you what that looks like, WinSCP. That is the tool that I use. If I go to Windows, and actually, you know what, it's right, let's see, WinSCP right here. So if I launch this, what I can actually do is I can, in this case, I already have one of my hosts added here, but I can actually log into that host. So I'm going to log in to this host right here with the root credentials. And the way this works is that WinSCP actually leverages SSH. So I'm going to hit login, and I will type in my root credentials again for this host right here and hit OK. And by the way, I don't know if you saw, the reason I didn't have to type in the IP or anything of the host is because I had previously SSH to it, or in this case, pulled files from it. So that's why. But in this case, that I did specifically put in the FQDN London compute1.home.lab. Now, once it logged in, you saw right here, it opened up and I see test.1 or test1.pcap. If I take this and I'm going to right click on it and download it, I just copy that file onto my local workstation. So at this point, I could go ahead and minimize this, and I could go ahead and close out of that. And I'm going to go ahead and right click on this capture file, and I'm just going to hit open, and that should open it within Wireshark. There we go. Look at this. So I'm going to maximize that. So what I'm doing now is actually looking at BFD. We can see that these are actual BFD packets. See, it says BFD control, and it's showing me a source of 1920 to 1953. So these two IPs right here, 53 and 52, are actually my edge nodes. So we are actually seeing packets to my edge nodes. So we learned in this video not only how to confirm the BFD is working, that we're seeing BFD packets being sent, but we also learned how to do a packet capture, which is probably way more important. And you actually got to see the process of not only capturing, but being able to get to the point where we could analyze it and start going through this file and figuring out exactly what's happening under the hood with BFD, or any other protocol for that matter. So that said, I hope you found this useful. I'll see you in the next lesson.